Hi, this is Robert Quimby, and I'm going to tell you about the Python package numpy. NumPy is the core of scientific computing with Python. So if you have a large sample of data and you want to do some operations, some mathematical operations on that data and reduce it and produce a result, NumPy is for you. So in this tutorial, we're going to quickly go over how you actually create arrays with NumPy. We're going to see how you can access those individual elements and get slices of those elements. We're going to do some of these basic mathematical operations on the arrays and show you some of the most useful functions that NumPy has available. There's quite a lot, but we're just going to give some of the most popular. And I'll give you a quick introduction to structured arrays in NumPy, which are a powerful data type. So as always, we're just giving a quick overview here. So if you want more detail, you can always check out numpy.org for the full details. And there is a NumPy tutorial, which has step-by-step instructions about what you can do with NumPy as well. All right, so why do we have this package at all? You should have already learned the basics of Python, and you know that you can have these list types, and you can hold basically series of numbers, much like an array, a mathematical array. But if you wanted to start doing some operations on this, it gets a little bit tricky. So one thing you might want to do, for example, we have these two lists here, list 1, list 2. You might want to add each of these lists together element by element. So each one of these columns you might want to add together to get a new list with the same number of columns in it, but the sum of all those elements. So you can do this in Python. The way you would do it is you create your new list. It's called list 3, and that would be the sum of these two lists. Now you can use that list comprehension to do this. You want to add each element, the A element in the first list to the B element in the second list. And you're going to do that for A and B and you have to zip together these two lists, 1 and list 2. And if you run that, you can actually get this sum here. So now we have this output, which is each column in this output list is the sum of the two input columns. So that's nice, and that works, but it's not super convenient. What you really might want to do is you might want to say something like list 3 is list 1 plus list 2. That's just much more intuitive. Right. So for other operations, you can, of course, always use this syntax, but we want to use this type. And if I type this right now, it's not going to do what you think it does. If I show this now, if I show what list 3 is, it's actually those two lists just appended to each other. Right. So we want to do the mathematical operation. All right, so how do we do that? Well, first thing we do is we're going to load the NumPy package. So we're going to do an import, and we're going to import NumPy. And we could just stop right there and run that, but most people, you'll see this very commonly, they provide an alias for NumPy. I guess they're too busy to type out all those letters, NUMPY. They just want to type out 2 letters. So they import NumPy as NP. So import NumPy as NP, and then we can refer to the NumPy package just with NP instead of with full NumPy. All right. So first thing we do, and now that we have NumPy, we can actually create NumPy arrays. So the way you create a NumPy array is you use the NumPy MP, because we didn't call it NumPy, we call it MP. MP.array. Use that function, and you pass this function an argument. And in this case, I'm passing it just a single list. So this has a list with 1, 2, 3, 4, 5, and I'm going to create another array with 3, 4, 2, 6, 4, just like we did before. But instead of creating 2 lists, now we're going to create 2 NumPy arrays, and we'll see how these are different. So I'll just run that, and I can ask what is A1, and it'll tell me that is an array with those data types. I can ask what's A2. Again, it's an array with that. And now here's the payoff, we can say what is A1 plus A2. And there we get our answer. So now we can use this much more natural syntax, and we can add arrays together. So there's more that we can do. It's not just adding arrays, of course. There's other mathematical operations. Say I want to take this first list here, and we're going to multiply everything by 2. I can just say 2, whoops, I want to be down here. I can say 2 times A1, and if I run this cell, then I get 2 times each element as my output. And you can do A1 to the power of 2. We can square all those elements, right? And there's other things you can do. You can actually take the square root of everything. You could raise it to the half power. That would work like this. Or you could use the built-in numpy function square root. This is probably a little better. It's a little bit more clear what you're doing if you type it like this. It's a little more in the Python style. All right. So numpy arrays are similar to Python lists in the sense that you can index parts of the data. You don't have to use the whole thing. If I just want that first element there, for example, I can say what is A1 of 0. Remember, it's 0 indexed, so 0 is the first element in that list. And I can, of course, do a slice like I did before. I can say what is A1 from, let's say, 2 to 4. And it'll give me 3 and 4, because that's the 0, 1, 2, 3, and then it doesn't give me 4, it just gives me, it stops at 4. So just get these two elements here. Okay. So these are one-dimensional arrays. Well, with NumPy, you can do two-dimensional arrays, or 3 or 4, or as many dimensions as you want. So let's give an example of a two-dimensional array, how you can construct that. There's many ways to construct these arrays. I'm just giving kind of the basic example here. I'm going to call this A2, and I'm going to set that equal to a NumPy array, so np.array. And I want to pass it, I have to pass it one thing now. I have to pass it a list that has two lists in it. So I'm going to do a 2x2 array. So I'm going to start by making a list. This is my square brackets. And then inside that, I'm going to make another list which has 1, 2. So that's my first row. And then my second row, I'm going to have 3, 4. So you can see what I have is a list of lists. And when you pass this to the NumPy array function, it realizes that you want this to be the first row and you want this to be the second row. And these are the columns. There's going to be 2 columns in each row. So I can run that, and I can print out what is A2. And it produces this array here. And it prints out a format that should look similar. It puts each row on a different line, but you can still see the square brackets to help you know how you constructed this. So if I want to access this first element here, since it's a two-dimensional array, I can ask for A of 0, 0, because I want the 0th row and the 0th column. So I can run that. Oops, I need to do A2 because that's my two-dimensional array. So A2 of 0, 0 is of course 1. And I can access the first column in the 0th row like this. So the rows come first in NumPy. Keep that in mind. So it's row, column indexed. So row 0, column 1 is 2. Right there. One more thing, by the way. So, since I can access individual elements, but I can also access an entire row. If I say give me the 0th row, it'll give me both these values in that 0th row. Or I can say well, give me the first row. It'll give me both of those values. Okay. So you should keep in mind that NumPy arrays are mutable. That means if I define an array like A, like this, okay. So first of all, I can assign. Remember, A is just the reference that we have in our environment, so that we can reference this list, which gets stored in the memory. I need to make this a NumPy array, right? So I'll make that a numpy array. And then I can say, I can run that cell. And I can say, what is A? Tell me it's an array. And I can set B equals A. Right? And then I can ask, what is B? And B is, of course, the same thing as A, because they're both pointing to the same part of the memory. That's what this assignment does. It doesn't create a new array, B. It actually creates just a new reference B that points to the same array that's already been stored in the memory. Right? So that means I can make a change to A. Let's say I want to change the third element, right, to 9. If I do that, I can ask what's A, and of course it changes the third element there to 9, but it does the same thing to B as well, right? Because B is the same as A. So we're working on references here. So A of 3 is we're referencing the part of the memory, and we're resetting that to 9. Okay. All right, so NumPy comes absolutely loaded with all kinds of helpful functions. One of the things you can do is you might want to create those counting numbers like I've been doing. I've been typing in 1, 2, 3, 4, but there's of course a built-in function that can do that. Say if I want an array with 5 elements in it, there we go, 0, 1, 2, 3, 4, 5. Just numpy.arange, and I put in the number of elements I want there. Maybe I want 9, maybe I want 1. Remember, it's 0 index, so it always starts with that. But you can put in however many numbers, and you'll get that range right there. Let's say I didn't want to start at 0. Maybe I wanted to start at 1, and I wanted to end at 9. I could do that. So it'll start at 1, it'll end. It won't include 9. It'll actually end before that. Right? So make sure you keep that in mind. If I wanted to include 9, I'd have to have a bigger number, like 10. And these don't have to be integers. I could have been 9.5. It'll count up. Now, since I have a decimal point, now it's all floating point, but it stops at 9. It doesn't go to 9.5. You can see it's counting by default. It's counting by ones, but we can change that. We can count by 0.5 if we want. Then we can get all these numbers evenly spaced, going from 0.5, 0.5 increments, all the way up to, but not including this limit here. Okay. Another helpful function is called linspace. This is a linear spacing of data points. So maybe I want to create numbers that go from 1 to 9, and I want 10 values. Right? I want to include 1. The first element should be 1, the last element should be 9, and there should be 10 total elements in this array. So if I run this, you can see what happens. My first element is 1, last element is 9, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements in this array. And since 1 through 9 inclusive only obviously includes 9 numbers, these are not integer spacings now. It figured out what that spacing should be, and it created the array to make that happen. All right, some more ways to make arrays. Sometimes you just want a blank array just filled with zeros. Maybe you want 5 zeros in an array. You can do that. Maybe you want a two-dimensional array. So you give it a tuple that has the shape that you care about. Maybe you want it to have 2 rows and 4 columns. And there you go. There's your 2 rows and your 4 columns. Related to zeros is ones. Maybe you want to create a ones array with, let's say, 4 rows and 2 columns. And there's your ones. Okay. And of course you can take this, and if you wanted 2s, you just multiply by 2, and there you got 2s. So these are helpful for creating arrays. There's of course some generic functions if you want to pass an array and compute the cosine of each one of those values. You can do that. You can take our A1 array and get the cosine for each one of these elements. Make sure you keep in mind that the value you pass here needs to be in radians. You can convert between degrees and radians using numpy radians, which will take a value in degrees and convert it to radians. Right? So that's radians, that's 90 degrees in radians. There's another function called degrees, of course, which takes radians and converts it into degrees. So just to show you, just if you've forgotten, 90 degrees is of course pi over 2. So numpy has a pi value built into it, 3.14, etc. You divide that by 2, and it says this is true. NumPy radians of 90 is equal to NumPy of pi divided by 2. There's some useful attributes that arrays have. If you want to know the shape of an array, you can ask it. Just dot shape. You don't need it. It's not a function. It's just an attribute. So this tells you that A2 is a 2 by 2 array. You might remember, just to remind you, A2 is this array here. And you can tell you what the size of it is. If you run this cell, it'll tell you how many elements total you have in your array. Some additional methods that you might find useful. Every array is built in with functions like mean. You can calculate the average value of the array. You can calculate the sum of the array. A very handy thing that you can do is you can actually calculate the mean along an axis. So if I print A2 here, so we have 1, 2, 3, 4, right? It's a 2 by 2 array. And if I want to calculate the mean value, that'll calculate the mean of the entire array, but I can calculate just the mean along a particular row, along the rows or along the columns. So if I say axis, this is a keyword argument, I can run that, and it will compute the average of this column and the average of this column, and give me the output there. And I could change this to the axis 1, and I'll get the average of each row now. This is the average of the first row and the average of the second row. There's that sum again. We can do that, and I should note that you can use axis for many of these methods. So this one will work as well. Now you get the sum along those axes. Some additional methods. There's max. It'll tell you what the maximum value in the array is. Of course, there's min, very similar method. You can also get argmin. It'll tell you where is that element. It's the 0th element. So in addition to integers and floating point numbers, you can have arrays actually of Boolean values, trues and falses. So if we take A1 and we ask it, where is it greater than 3, it'll tell us that the last 2 elements, that's true, but the first 3 elements, that's false. So we can create this Boolean array just with this simple expression here. Now these truth arrays are actually very, very useful. There's a very important property that we have. So first I'm going to define a variable called w, which is going to be equal to this truth array we just created here, right? So I can run that. And what that does, again, it just sets w equal to this truth array. And then what I could do is I could say, well, let's take A1, and if I put w, if I get the indices, if I use this kind of syntax, it'll just give me the elements in A1 that are true, like that. So A1 is 1, 2, 3, 4, 5, and if I just select the ones that are greater than 3, it just gives me 4 and 5. So this statement gives me this new value. And so why would you want to do this? Well, maybe you want to find those elements that are greater than 3 and you want to change their value. So you can say now A1 of w equals 9, or whatever you want to set it to. And you can print out A1 and it'll change those last 2 values to 9. So there's a lot you can do with this. This is just kind of the tip of the iceberg here, but this is very, very useful. So one last data type I want to introduce to you is called structured arrays. This is just a special type of a NumPy array. So you may have noticed that these, if I look at A2 for example, right? It's just a simple array, and each one of these values is an integer. I could have defined this so that it was floating point numbers, but the only way I can index these is by the row and column. Sometimes that's not super convenient. Sometimes I want the 0th row, and we know how to do that, but sometimes I just want this first column here, right? And we can do that, of course, with indexes, with integer indexes, but it's also, it might be convenient sometimes to give this a name, to call this something. So that's what we're going to do now. We're actually going to give names to the columns in our array. So the way we do this is we define what the data type is going to be for this array. So I'm going to call this dtype, and I'm going to start it off as just an empty list, and we're just going to append values to it. So we'll build up our data type here. So I'm going to take dtype now, and I'm going to append, and in this argument here I'm going to define a tuple, and this tuple is going to be first the name of the first column. Let's just call the first column x, and the data type, let's make it an integer, just int. Okay, so that's our first column, and let's make this a 2-column array. So let's change, we'll append another value, and we'll call this one y, and instead of making an integer, let's make it a float. Okay, so now we have our data type defined. Let me just see what that looks like. So it's just x, which is an integer, and y, which is going to be a float. And now we can define an array using this. So let's have an array that has 5 values in it. All right, 5 rows. That's the number of rows. And we're going to start with zeros. So we're just going to find a new array A, which is going to be our numpy zeros. And we're going to have n rows in it. This could be generically could be a shape parameter. We could give it a shape, but I'm just going to make it simple and do rows. And then each one of these rows is going to have this data type. So we say dtype equals dtype. Okay. So when we've done that, here's what we did. We just defined this array, and all the values are 0. But you see in each row we have an integer and we have a floating point number. And we can refer to those now as x and y. So if I say give me a of x, just give me the x values, there it is. It prints out those zeros. Or if I say a of y, it'll print out those. Now it's not very interesting because they're all zeros, so let's change this up. Let's actually define now the a values to be just the numbers, the first 5 numbers. So we'll say numpy, we're going to we're going to change the values now. We're going to change the values of x to a range, and we'll have n values there. And then if I print out what is a of x after I do this, you can see what we did. We just reset the a values to 1, 2, 3, 4. Right? And after we've done this, we can maybe change the y values to be the x values squared. And we'll print out a of y. And you can see we get our squared values there. So again, this is just kind of the tip of the iceberg, but you hopefully can see how powerful this will be. We now have this array where we can refer to things by name. We can say this column is going to be called x, and this one's going to be called y. And we can do operations on them, and we can keep this all together. This is all, remember, just together in one package. This is just A. A has all this information in it. So we can pass around A, we can take things in this array, take them in and out, change their values, and it all keeps together in one package. So there's a whole lot more you can do with NumPy. If you want to see more about the structured arrays, you can check out the documentation online. This is very handy to give you some more examples. You can get some idea of how powerful this is. And if you want to know more about NumPy itself, you can just ask it. You can ask Python about your variables. So we defined A2 before. If you want to know what methods and attributes are available, you can just run dir on that. That dir function will tell you all the different methods that are available, and some of these are things we went over already, like argmin, and there's argmax. But there's a whole bunch of other things that you can do with this. You might want to learn what flatten is on a 2-dimensional array, or what resize does. You can probably guess. We have sum and std, all these important things in here that we're going to use. And if you want a little bit more help than just what their names are, you can also use help, of course, on there. If you run this, and it'll tell you in great detail what the help is for each one of those functions and attributes. So you can look through this, and hopefully you'll learn a lot about what you can do with NumPy arrays. All right.